Okay, for this problem, it says monthly payments of $200 are paid into an annuity beginning on January 31st with a yearly interest rate of 6% compounded monthly. And then it says add the future values of each payment to calculate the total value. We're not going to do that part. I'm just going to block that part out. You don't have to add them together. Just find this is the part we're going to do. Find the total value of the annuity on September 1st. Okay, so let's see. The annuity formula is A is equal to R times, I think I'm writing too big. Let me go a little smaller here. Sorry. Okay. A is equal to R times 1 plus R over M raised to the nth minus 1 all divided by an R over M. And then they tell me that monthly payments, let's see, monthly payments of $200, that is R, so put 200 there, are paid into an annuity beginning on January 31st with a yearly interest rate of, the interest rate is 6%. Remember, you have to write that as 0.06. That's going to go here and here. And then it tells me that it is compounded monthly. So M is a 12. That's what's going to go here and here. And then remember that N is equal to M times T, and M is the monthly compounding, so that is 12. Oops. And then time is supposed to be in years, but you're not doing it for a full year. You are starting, you're beginning on January 31st, and then it's actually ending on August 31st because the total value of the annuity on September 1st. So we're doing January, February, March, April, May, June, July, and August. Each of these on the 31st of the month, or whatever that, you know, February doesn't have 28 days, but it's each day of the month. So at the end of each month, and that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 months out of the 12 months in a year. And if you take 12 times 8 12s, the 12s just cancel and you get 8. So N is going to be 8, which is going to go here. All right. So now I take out all the letters and I put in the numbers. The pink was 200 times 1 plus blue is 6%, that's 0.06 over green is monthly, that's 12, and purple is 8. And then I have another 0.06 over 12 in the denominator. And now, using your calculator the way I showed you in class, you can type it in exactly as you see it. And unfortunately, I don't have my calculator here at home, so I have to use a different calculator. I'm going to pause while I do the math. Hang on a second. And after I did that all on my calculator, I got $1,628, and rounded to the nearest penny would be 28 cents. That should be the value of this annuity. So I'm going to go back to my math lab. Here it is, and I'm going to type it in. 1628.28. Fantastic. All right, so you don't have to add the future values of each payment. In class, I showed you a table where they did it, but I'm like, no, we're not doing that. We just use the formula. So just figure out the total value of the annuity. The tricky part was that they were only starting on January 31st, and they were only going through August. This says August. That's horrible handwriting on my part. So at the end of August, they would recalculate it. So on September 1st, that's how much money you would see in your account. And that is only 8 months out of the 12 months in a year, because time in all of these problems is always in years. So if it's not a full year, you have to figure out what fraction of a year it is. And if we're talking about months, it'll be the number of months out of 12. If you're talking about days, it would be the number of days out of 365. So I hope that helps.